Hello, and welcome to this edition of EMS Now Up Close. I am Eric Miskell with EMS Now, coming you today from Nashville, Tennessee, where I happen to be on a stopover, so a little out of my element here. It's my pleasure today to be speaking again with Michael Ford. Michael, of course, is the Senior Director of Emerging Industry Strategy with Aegis Software. Those of you going to Productronica will have an opportunity to meet Michael and speak with him in person there. So, Michael, it's always a pleasure to speak to you, sir. Welcome aboard again.
Yes, thank you very much. Thanks for having me.
Yeah. Listen, I wanted to talk kind of going into Productronica. That's the big event. We're in the season again, right? So that's in 2 weeks. Tell me about what Aegis has planned and the message you're bringing to the industry there.
Yeah, we have a kind of age-old message for those looking toward getting into MES. Because I don't know about you, but whenever I look at a new piece of software, even updates of Office, I keep looking at it and thinking, wow, this is complicated. I just want to write a little bit of an article or something like that, and yet there's this title bar, loads and loads of options that I'm never going to use. And people kind of think about that when they see a new MES system. They think, wow, this is a lot. This is going to be very complicated. And, manufacturing is complex. So, obviously the software around it's going to have to be a little bit clever. But then people are thinking, well, could I get a really simple solution? And, just to do the job that I want it to do. What's the harm in that? Just to get started. So a kind of analogy I kind of make is trying to find that sweet spot. And with a car, if you're driving a car, way back when I first started driving, you come across something in the road and you put your foot on the brake, and it was simple. Little pedal, spring on it, a bit of hydraulic fluid, pads go together, and hopefully the car stops. And so we spent so many years trying to take out that word hopefully. So we put a little pump on there to make the brakes stronger, but then they were too strong, so we have ABS to stop the wheels locking up. But then you still get into trouble depending if you're steering right or steering left. And what about if it's a wet day? What if you're going uphill or downhill? There are now hundreds of computers in a car, many of which are there simply so that when you press that pedal, it's going to stop. And there's no maybe or hopefully about it, notwithstanding the laws of physics, but it's going to do what you want it to do. And I think that MES is kind of the same. We shouldn't be seeing all of these myriad of functions that we maybe never use. They should be built in. So it's simple on the outside. You just push the pedal, you get your production going, everything's great. But on the inside, those decisions are being supported by a lot of built-in, the built-in data model and ontology. Lots of decisions are being made. After all, most of us, we've done production before. We get a new product in. It's not rocket science. We kind of know what's going to happen. So why do we need to go through all of the different processes? And so this is one of the themes we're talking about. MES, it's got to be simple on the outside, but smart on the inside.
Okay, so it's really making the complex the complex simple, right? So being able to do all the hard work, and so that users simply can, as you say, step on the pedal, hit the key, whatever it is.
Yeah, this is it. And we call it kind of composability. And for us, this means that, rather than reinventing every step as we go along, we simply put together things that we already have and just shape what we'd like. So this product, I'd like it to go on this configuration or maybe that configuration, depending on the customer choice. I don't want there to be any difficulty in that. I don't want to have to reprogram. I don't want to have to rebalance. I don't want to do any of those things. That should be automatic. So I simply want to say this product, this configuration, let's go. Oh, and a warning comes up because calculations in the background are helping me to manage materials, for example, to let me know that everything's going to be okay. I'm too early, I'm too late. So, you've got that sense of some intelligence that's supporting what you're doing, looking at the millions of things that as a human, you can't really do. So
Right.
composability means making a very simple, like user interface or work instructions, maybe a logistics task, maybe a KPI, doing it in a very, very simple way, supported by that intelligence.
Yeah. And the composability to me is a very interesting term to apply here, right? So you're really kind of combining various things to make a larger, greater system, I guess would be the term, right? So, but is that really on an a la carte almost basis? So every client could kind of pick and choose the elements that they want?
Yes. The
He says hesitantly, look at
Well,
that.
yeah, because the broadest value, the most value comes from the broadest solution, actually. Because if you're taking into account materials or operator availability, and there are so many different things you might. So within an MES world, you kind of do have visibility of all of these things because we're collecting data in real time using IIoT. Standards like CFX are being used, plus our hundreds of interfaces. And they're all being, the data is collected in a standard way. And this means that you can bring context to it because data on its own is worth nothing. Actually, it's just a cost, in fact, of storage and formatting. But when you start to use it, when you put it together with what is the product, what is the configuration I want to use, what are we doing at the moment, where are these materials, what is this guy doing, you start to be able to create that context. And these are the many decisions that are made in the background by our software that then helps the human make their decision about, I want to respond to a customer request, I want to do this planning, I want to deliver these work instructions in time. All of that is now being supported. So it is the context and the built-in data model that you get. But the wider you have that data model, the more modules that you have, then obviously the greater the kind of insights that you get from those algorithms.
That's interesting. And I like your analogy of the car actually, because I was thinking as I hear you speaking, I'm thinking of the EVs of today. They say it has so much built into it. It's really it's a matter of turning on the systems within it, right? When you purchase a car, can it do this or that? Well, ultimately, it's hitting a switch and electronically turning something on that's already built into the overall system. And it sounds like that's a lot of what you're talking about.
Yeah, it's interesting to see how things evolve because with EVs, when you press the brake pedal, the brakes don't work. It's actually starting energy regeneration. And so you're actually building a sustainable model for your braking system. So how does that work in manufacturing? Where we have Industry 4.0 now, and we need to be more agile for changing customer demands. We don't want to be forced to follow decisions we've made a month ago because that seemed like a good idea at the time. We want to be, oh, there's a new opportunity. I need to change something. I need now the support of all of these systems to help me make that decision, make sure my factory is going to be still balanced and optimal after making those kind of decisions. So yeah, things do evolve all the time.
Tell me, how does the system also help on the quality side, to ensure the quality of the products? How does that element of it work?
Quality is an interesting thing because people have been driving toward zero defects for quite some time. Will we ever get there? I kind of think we will. And it's an interesting combination because you need to get results from testing and inspection. People still
Hmm.
argue about whether that's valuable because if you built a good product, why do you need to test it? Okay, but you've got that information. We're now using that information not to only discover defects, but actually to prevent defects from happening. So the Kappa and Fracas processes that are built into our software say that, okay, if you've got an event, find the root cause and then create an action that prevents that cause from recurring.
Yeah.
So this is very, very interesting that you can start to build these things in. And if you do that in a digital world, then you don't have endless bits of paper for people to follow. This is the way I should do it. This is the way I shouldn't do it. And by the time you're finished, oh, I'm too late. Therefore, I never look at the paper. Now it's in the digital realm. It's automatically guiding you toward best practices. And we see the future of this in the analytics side, where the more you analyze the data that you have, the more insights that you get and the more ability to help your decision making. And this is happening on two levels. You have the live shop floor level where we are using that data to avoid those kinds of defects from ever taking place. But then you also have the longer term view from analysis of the data over a long period of time.
Yeah. And speak to the AI element of that too, because obviously the system has the AI inherent in it. You have the algorithms in there, as you're saying, to make sense of that data and turn it into something valuable and insightful and beneficial.
AI is an interesting direction because a lot of talk right now about whether you trust AI, how do you control AI, and all the rest of it. And the fact is that these almost free bits of software now are available for anybody to generate AI, and we see a lot of interesting projects. Universities looking into predictive or preventative maintenance, quality, again, one of the key things, even energy management. And so the question is, can we do everything? Could you buy all of the AI in the whole world from Aegis? And basically, a lot of it is already built into our real-time area, so that's okay. But a lot of it is going to be, especially the new areas where people are now developing those algorithms, they're going to be part of an ecosystem. Now, people are talking about an ecosystem from the wrong perspective today. They talk about an ecosystem as being able to share bits of software code and being able to create their little AI application. I don't like that because, okay, it's nice to have the AI, but it's a little bit of a risk when you don't really know what the AI is going to do, because did the person who designed that AI have your use case in mind, or did they think about something else? So in the Aegis approach to AI, we want people to try AI as much as possible. And that the use of the data from Factory Logics, which is not just the raw data, remember, it's all contextualized now, it all has meaning. That meaningful data goes up into the AI, or AIs, many AIs potentially. Those AIs will do their bit, and they will work well because the data is contextualized. So they've got an easy job, relatively, which means they'll create better value. But we don't want them necessarily then automatically doing something in the factory. Actually, what they should be doing is bringing insights back to be executed by our MES. So it will come down with a recommendation. You need to do a predictive maintenance job on this certain machine. You need to adjust this parameter on this machine to ensure quality. Or you need to take care because this particular line is starting to run late, and if it continues to do so, a delivery will be missed. So there are going to be many different AIs, each of which focus on these different areas, and they are going to bring their insights or results to people or to the MES to then action and confirm. So then you have better learning for the whole AI based on real world results.
You know, that's interesting because I heard recently the analogy, they call it the AI sandwich, that you have to put people, then AI, then people again, right? The people need to design it and create it. Let AI do what it's being instructed to do, but then have humans again look at it and kind of validate it to say, yeah, that is what we wanted, right? This is the intention, or it's feeding to that. But in your example there, that would the AI would put it back within the MES, and the MES has been programmed to kind of make sense. Or is there still that human element there that's going to say, ah, yeah, that's right?
Yeah, it depends on trust. For example, one of the things we do today is to provide a replenishment material. I mean, how easy can that be? I mean, you just go straight to the warehouse and get it. No, 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 no. You have to calculate how many products am I making, how many materials are being used, how much spoilage is being used. Okay, when is the next replenishment due? How long do the logistics take to get that? Where is the optimum material located? I need to verify it, scan it. Again, you're talking about all these different computers as in the braking system. It's all built into the software. So sometimes you can trust the computer to make the decisions, and your level of trust depends on your past performance with certain AIs or certain functions that have happened. So we see that in the future, people will have the first decision. And then after that, okay, maybe this is now trusted, it's automatic. We can make it just work as part of the operation.
Okay, interesting. Now, the other topic I wanted to make sure to touch on with you, and you've mentioned it once in your explanation, there was the whole issue of sustainability, and that
Mm.
is obviously becoming increasingly important within the industry, and requirements, for that vary. Um, how does Aegis help with that?
People have said to me that they're panicking a little bit now because of the requirements to report CO2 emission for products that are being made. And they call it different scopes. You've got scope 1, 2, and 3. I mean, scope 1 is how much energy do you use actually in the machine doing something actively. Scope 2 is what about the rest of the factory that's not actively contributing to that production. But then you have scope 3, which is what is the contribution of CO2 emission from the materials that come in. That's where it gets tricky, because you've got to start to put together your traceability information. So you know IPC CFX. This is what we adopt for factory logics, and it is capable of gathering energy information usage. So scope 1 and 2 can be easily satisfied. We also have traceability data, material traceability. So it tells you exactly which materials were associated with which product. So within the MES area, it is absolutely essential that you have those facilities available in order to build your sustainable information. Where
Yeah.
we're taking it one step further is with IPC, with the sustainability standard, where we are working out how do we exchange this information throughout the supply network. Because I don't want to share my traceability data with anyone. I don't want to, it affects my privacy. It may even reflect IP leakage. So we are creating a mechanism for credentials, which are based on the W3C standard, verifiable credentials, that allows the exchange of facts, which is supported as a digital proof based on your MES data, rather than actually sharing the data itself. So that then all of the reporting requirements can be fulfilled with these facts that are exchanged, retaining privacy, retaining IP, but you're fulfilling the requirements of reporting. So how do you then create an infrastructure throughout the whole industry? Because back to the car again, you've got what, 100, 200 computers in there? That's all electronics. But what about the tires? What about the windscreen? What about the battery? So
Yeah.
you're crossing different verticals, actually different supply networks. And so how do you make one ecosystem where everybody can play fairly? It's going to be very cost effective. It's going to ensure privacy and intellectual protection, intellectual property, and be able to provide those credentials that satisfy the reporting requirements, all of which is based on data that you collected as you do today using your MES like factory logics. So,
Interesting.
yeah.
No, it's so I hear you as I hear you speaking about what comes to mind is I remember when the Rojas we came in and everybody said all the additional information that had to be gathered and provided on the components and every little component and what's going into it and is it compliant or not. Is this and the industry adjusted to that, obviously, right? The systems right? I mean, in gathering that information and moving it forward to push it further down. Is that essentially what's going to happen here in the sustainability too in this regards? That all these different suppliers become required to be able to share that data and push it up with their with it?
The gut reaction to all of what you've just talked about is no.
Mm.
Everybody says no. They say no because it's extra cost, it's an extra burden, it's a threat to IP leakage. Remember when we had lead free and we were trying to put a mark on the component to indicate that it was lead free? It took years for people to first understand the requirement, understand that they had to do it, understand the cost, and then actually do it. It was an absolute nightmare. And that's just for one character. Now imagine we're asking people to divulge divulge information about their entire supply network. You can imagine how big that no is. And this is what we're trying to break down, because we know already through factory logics that all of the information we use within manufacturing is like gold. You can use it for so many things. But now you have to start sharing it. Governments are mandating it.
Mm-hmm.
How do you turn that no into a, okay, I'm comfortable to share fact based on my data. I'm not losing my intellectual property. I still retain my privacy. In fact, all of my data stays here. I don't just shove it into a cloud somewhere where it costs me an enormous amount of money. Not to, I mean, ironically, there's the sustainability of all of those servers, which use more electricity than a small country. So, you've got to keep your data under control, safe and secure and private, but also provide that necessary fact. So it's all about getting, first of all, at the C level, the understanding that we're not giving something away, that we are creating value from this, that it doesn't actually cost very much because you're using your MES system as you would anyway. These new technologies from W3C are really helping, providing to do what is necessary in the digital domain without this sharing of data. So it's a very, very interesting time, and we'll be presenting about this at Productronica as well. One related to CFX and the data collection within the shop floor, but also then about the new sustainability standard and how that entire ecosystem works.
Perfect. That was a good way to kind of pull it all back to Productronica, which was where I was going to go next. So tell us about that. Are you presenting there, by the way? Are you?
Yes. There are a couple of slots in the CFX area that I'll be associated in. I think there are going to be 5 different presentations, short presentations within an hour slot about CFX and some of the real world values. I think people understand that it's real now. We don't need to prove that. I mean, so many huge companies have adopted it as their internal standard. So, it's up and running. So now it's a matter of explaining the values. So we'll have different perspectives on that, like closed loops, like analytics, sustainability. So I'll be involved in those. And as well as that, IPC has a separate track for sustainability, where again, different aspects of that, the bare PCB, the management perspective, and I'll be talking a little bit about that standard as well.
Okay, excellent. Well, I unfortunately will not be at Productronica this year, but I know it's going to be, everybody's excited, right? At the end of the year to get together again. I know there's a lot coming out there. You will be at the booth as well if people wish to meet and interact with you. I'm assuming you'll be around the Aegis booth some.
Yeah. We have a good team there. Everybody wants to go. It's the big show in Europe. So yeah, it's best to book an appointment because it is so busy. It's just unbelievable. So many meetings. You think a week is going to take a really long time, but it's going to be over in an instant. So yeah, we're preparing for a very busy week, and we really do want to talk to people. Obviously, of course, customers, people looking to become familiar with MES, be not afraid of something that's too big and complicated, rather
Right.
something that is going to really help them push that pedal and accelerate manufacturing, but also about things like sustainability, because people are a little bit afraid about the impact on manufacturing, the cost, the risk, the burden, if you like. If fair is fair and there is something that we need to do, we've found the minimum cost solution. Sorry, but that has to be taken. But where they misunderstand and they think it's going to be worse than it is, and they start to steer away from it because they just aren't sure or don't know, I'd like to help in that situation. I'd like to make sense of all of these different rules, regulations, things that are coming out, and potential solutions as well, so that people can really have an informed decision about where they're going to take their company in terms of sustainability. We'll actually have one person explaining exactly that at the IPC booth, so that people need not be afraid of these things, and those who do these things actually turn the kind of burden into a benefit. And it's very interesting to do that, because saving energy, guess what, it saves money.
Yeah,
So,
exactly.
you know,
That's right.
there are
Energy
all
is not
silver
free, is
linings.
it? Yeah, right. Excuse me. That's very good. Listen, I will encourage people to certainly reach out to Michael and to Aegis. Like he said, they're filling up. So if there's you see this or an interest, act quickly. I love the message that's simple on the outside, smart on the inside. I think that's a good way to kind of conceptualize the solutions that you bring to market. So Michael, it's always a pleasure. I always feel like my brain's been stimulated when I speak to you. So I really appreciate that. Enjoy these conversations. I wish you success at Productronica and hope to speak to you again in the future, sir.
Okay, thank you very much indeed. It's been great to be here.
Indeed. Thank you, sir.
Thanks.